here's quite a collection of different animations which will help you to understand different things about magnetism. So just we'll quickly summarize this. This is just introductions to field lines around a bar magnet or field lines in general. We can see that the field lines are showing the direction that a North Pole would point. If we had so a compass is nothing more than a tiny little magnet that is free to move. And you can see that the North Pole, which is this red part, is always pointing towards the South Pole, or obviously away from the North Pole, because like poles repel and opposites attract. So north repels north, and south repels south, and north attracts the south. And so if we join these sort of arrows up, we get this kind of pattern that looks like this, and that's what the field lines around a bar magnet look like. You can discover this for yourself with iron filings by what's happened here is they've put a piece of paper on top of a magnet and then sprinkled some iron filings over the top, and then given it a little bit of a shake, and then you can see these kind of pattern here which looks like this one here. This over here is just like a kind of a 3D picture of these forces around these field lines around a magnet using iron filings. In reality, if you did this, the iron filings would of course just get attracted to the magnet. So you couldn't really, I can't think of a way you can make this happen, but it's quite a good animation anyway. If you click on the little link up there, you can have a little play with them all. So that one's not an animation, but the rest of them are. This shows that actually magnetic fields are around all wires, not just magnets, but actually around electric. If there's a current going through the wire, then there is going to be a magnetic field around it, and actually goes in a little circle, like it orbits it. And the way that the direction of the magnetic field is based on the direction of the electric current. So and you can use something called the right-hand rule. And what you do is you point your thumb in the direction of the current, and the direction that your fingers are curling, they show the direction that the magnetic field is going around the wire. You can see these compasses are showing the direction of the magnetic field, and I've drawn them around there. What did we look at next? So that was us discovering that there's magnetic field lines around a wire. This is just another animation to just show the same thing. It shows you can do a couple of other things with it, change the size of the current, and you can see the iron filings experiment there. So play around with that one. Again, click the link up there. Now we know that you can produce a electric. Sorry, let me start again. Now we know that you can have a magnetic field around a wire. We can actually amplify that using to produce an electromagnet. So if we get these wires into a coil, then it ends up amplifying the process. I'm just going to check to see. Okay, and so so you end up with something that has a much stronger magnetic field than just a regular wire, because as it goes around, it keeps amplifying it. The type of magnetic field around an electromagnet is the same as the magnetic field around a bar magnet. Okay, so these are called electromagnets. Over here is a whoops, I didn't know that wasn't locked. Over here is a diagram or simulation showing how a speaker works using the process of electromagnets and an alternating current being produced by the MP3 player or the music player. Again, click on here to have a little play with that. So that's your electromagnets and uses of electromagnets. We then saw that you can actually produce electricity using a magnetic field. So if you using a magnet and some wires, if the wires are actually cutting the magnetic field lines, then a current is set up within the actual wires itself. I'm just going to stop that video there as part 1, because they're capping me at 5 minutes at the moment, so I'll just save that there.